Good afternoon. Oh, let me just stop my music for those who came in and they were listening to the music. Did anybody recognize the music? Did anybody ever see the movie The Fifth Element? Yes, there's people here. So, Fifth Element, beautiful movie by Luc Besson, a Frenchman. It's a little bit of a tribute to you, Patrick, maybe. The Fifth Element is a movie about a fifth element, which is actually protector of life. And in that movie, there's a wonderful actress called Mila Jovovich. I don't know where she's from. She's from around these parts, but I can't remember where she's Serbian or Yugoslavian or from here. I don't know. But at a certain point in time, they're looking at hieroglyphics. And the guy is reading, it's about the elements of life, and in their possession are the 4 elements of life. You know, water, earth, fire, wind. And they are gathered around the fifth, the supreme being, the protector of life. It's a Greek guy who's actually saying this, and to protect life. So the 4 elements here represent everything that we do today. I think I have to wait a little bit because everybody's slow coming in. Everybody's breaking the entrance, but it's okay. Actually, I can map this entire description of the fifth element to what we do today in software development and software solution building. It's not only about software coding, but it's also everything who's involved in solution building. So if you're building a PaaS, if you're building internal tooling, if you're building whatever, there's always an entire flow and an entire army of people involved. And this is really about that fifth element, the security that is typically missing in these kind of projects. I want to give you up to speed where a developer can make the difference. And we're going to talk a little bit about shift left, but also where in the entire life cycle of now solution, not an application, but of a solution, security can make a difference from any point of view. My name is Mike Martin, as I was already nicely introduced. You're cold? Grab a jacket. I was already nicely introduced by my wonderful colleague on stage here. I work for Microsoft as a cloud solution architect, and I work on a daily basis with ISVs, independent software vendors. So think of these people as Infragistics, SAPs, those kind of collaborations that are happening. And I advise them on a daily basis what they should do and how they should build their software to make it more scalable, reliable, but also even more secure. And I talk a lot to developers. I slap them a lot. Yeah, sorry, I have no filter whatsoever. Don't worry, I will not start swearing, but if I do, please forgive me, then it's by accident. Oh, by the way, if you have any questions, I will be around. There will be no time for questions during. I can try, but there's not enough time for that. But if you do have any questions or you want to really hold me, just throw something at me. I will try to dodge it anyway. Please, no chairs. I mean, the people have a lot of issues setting these things up, so it's always a thing. So if you want to follow me on social media, you get all my links there. You get my email, you get my Twitter, though maybe I will abandon that someday because that's kind of going down the thing. And you also have my LinkedIn, so hopefully this will help you if you have any more questions. For some storytelling, we all remember 2020. Typically, we all remember that thanks to this little pandemic going on, COVID thing. Yeah? We try to forget about that. But also something else happened in that year. A small company called SolarWinds had a little incident with their tooling. Now, small was being sarcastic because SolarWinds is actually one of the widest used monitoring tools in the world on server and internal landscapes. And what happened there is that somebody got access through a spear phishing attack, and they got access to a small part into the organization, which was actually the live build system. And to make it even more worse, not only SolarWinds was impacted, but also the build system builders, JetBrains for that matter, who were falsely accused of being an obscure little company from the Balkan area. Unfortunately, people, I'm not making this up. They sued the New York Post for that, by the way, but it was JetBrains. And do note that JetBrains is the second largest dev tooling builder in the world, next to Microsoft. So I was kind of surprised to hear that then. So what happened there basically is somebody got access to a mail account from an engineer. That engineer had so much power over the misconfigured TeamCity build system that the Spearfisher attacker got instant access to that system, and they were able to inject code during build time. And this is where shit went wrong. Told you, no filter. What happened is that SolarWinds got deployed to all the networks where the latest version was going to be installed, and all of a sudden we had a ransomware mass attack happening. So thanks to SolarWinds, this little thing happened. A supply chain, oh, I need to step back, wrong button. A software supply chain attack happened. So you got a weak access somewhere, somebody works their way up to the chain, and they're doing a full attack onto the endpoint, which is the customers of the product that are being involved there. What basically happened, and this is the beauty of it, the developers of that hack, so the malicious actors, they actually only injected that little red square over there. And I will try to read it for you. There's a try catch. So they were good developers. They even were catching for their exceptions. Of course, you don't want to be caught in red-handed, right? And what they injected there was basically an additional thread that was going to scan and call an additional injected DLL, which was overforged into a DLL name that they had. And this would do all the bad things at their end. So in the end, what they would do is, through that DLL, they would give a command and conquer DNS name, which has been taken successfully down by us, by the way. Microsoft, we have a Microsoft Security Center that is constantly pulling threat intelligence over the internet, and also we try to take down these things. So there's a response center. And they downloaded zip files onto the machines, which gave them, again, command and conquer through additional endpoints towards the networks where SolarWinds was engaged. So this was a huge, huge attack surface, because knowing that SolarWinds has a lot of customers, large companies that are heavily investing into these monitoring tools. Now, why am I telling you this? And this is the agenda of, oh, I'm a little bit too fast. This is the agenda of the day. I've already been telling stories here, but this is the agenda of the day. I'm going to talk about secure design, bring back to the secure coding principles, and then talk about the other two elements, building and deploying and monitoring. Knowing that security handling end-to-end is a story that everybody concerns. It's not only about the system integrators, the firewall. For God's sake, if you're doing security, a firewall will not cut it. I want to hear you say it. Firewalls don't cut it. Come on, guys. I know it's after lunch. Firewalls don't cut it. There we go. That's, at least you're awake. You want me to yell harder? I can do that. I mean, I'm from Antwerp. I'm from Belgium. I'm sorry about that part, but we can make a lot of noise. So, yeah, but bear with me. So, what I'm basically going to talk to you about is how a developer can be importing end-to-end security, how it fits into something called the Security Development Lifecycle, or the SDLC, and where you can make a difference. And if we talk about the SDLC, or the Security Development Lifecycle, typically it's SSDLC, so Security Software Development Lifecycle, we need to take into account a couple of things. And one of the things that are really important is the most, for you guys, the most left-hand part, is the education part. If you're not aware of what could possibly go wrong, and believe me, a lot can go wrong, then what's the use? If you don't know that you're doing something wrong, or if you don't know that you're injecting something which is really dangerous, well, how can you do a better job than in the near future? So this is something that you need to start working on. As an organization, you need to make sure that everybody in your organization is aware and trained on certain security risks. That doesn't mean that they all have to be all of a sudden security analysts, but at least they need to know that certain things are not done. passwords passing through, for instance. Luckily, these days have passed, but it's these little things that make it happen. And onto the process, you have a lot of other stuff going on, up until the last part, which is the incident response. You, as a company, specifically if you're publicly facing, you as a company also need to know how to respond when there was an incident, how to respond when there was a security failure, how to respond when there was data leakage, and so on and so on. And for this, you need an incident response plan. So we break that down into a couple of things. As I said, provide training and make sure that everybody is aware. At Microsoft, we're really good at that. At least every year, we get at least 3 security trainings. And one of them is even made into a Netflix kind of show. And I'm always looking forward to that. We all love Nelson. Nelson! That's internal joking, but those guys really do it really well to involve everybody into the security aspect, ranging from secure computing to secure handling of data. The second thing is that you also need to make sure that you do secure designing, and that starts with security requirements. How are we going to deploy it? Where are we going to push it? What are regularity, compliances? Darn it, that's a mouthful. And how are we going to report to those things, right? We move over to the threat modeling part, making sure that design requirements have been established. And then for more of these things, we define maybe if we need to do confidential computing, cryptography, all these things. And then we start more playing into the ecosystem where most of you hopefully are. I think everybody here is a developer, or is there more QA engineers here, or what is it? Who's the developer here? Okay, most people of the room, good. But also for the quality engineers, testing engineers, this is important for you too. Because you need to make sure that all the tools that you're using are approved, are well checked on every single level. Because as a testing engineer, hey, I'm going to use this small module that some playwright engineer outside of the field is using. Or even somebody injected something in Selenium and you don't know. You need to check these things. And then we move over into the more tooling capabilities like SAST and DAST. The difference is that one is being done at a statical way, the other is being done more dynamically once you've deployed it into test. And then we move on to penetration testing. Oh yeah, by the way, penetration testing, we do that in production. Yes. Why? Because you want to make sure that production can also fail. The guys that are doing the testing for you, they know what they're doing, or should be knowing what they're doing. And most of all, establish a standard incident response process. For that, we have templates, for instance. We can help you as Microsoft. Look onto the Microsoft Learn pages for standard incident response pages, and we get like 7 templates specifically for each of the industries. Very useful. Now, I'm already like 15 minutes in. Darn it, I hate this talk because typically this talk has 2,000 slides and a story of 4.5 hours. So I asked preliminarily to close the doors and lock them so you cannot get out. At least you are awake. But I'm going to try to talk to you about most of these things anyway. And I'll try to do it in a very speedy way. Take it from me, I took this challenge last year for 25 minutes. Never doing that again. Still I'm out of voice. One of the things that I do want to mention is that you have to handle zero trust principles. We today are focusing, and Patrick mentioned it earlier in his keynote, we are today focusing also on something called Secure Future Initiative, making sure that everything is secure by design, but also secure by trust. And why zero trust? What is the basic of zero trust? It's first of all, you want to verify explicitly each of the users, each of the sources, where it is coming from, I want to know who you are. Hence why an identity is so important. Identity is your first part of protection. It's not a firewall, identity. Because your identity passes on through any kind of system that you have. Today we make it very easy to do single sign-on, but if that single sign-on is being abused, well, guess what? SolarWinds. You see where I'm going with? Second of all, make sure that at any aspect of your identity lifecycle or whatever you're going to do with the identities in the end, make sure that you use the principle of least privilege. If you don't need that admin access, you will not get it. All right? So, who here needs to be an admin? Nobody. Nobody needs an admin, but you need just-in-time rights to do certain things. That doesn't mean that you will not get privileges. You will get privileges. You will get those security reading change modus. You will get that security uphold stuff. You will get that deployment role, but you need to ask it in advance and have a certain mechanism around that. And the last of all, very important part is assume breach. The average lifespan of a malicious actor inside of a enterprise, let's call it like that, is typically what? Anybody dare to do a guess? What's the average time that they spend already inside of your network before they actually get detected? Seconds? Yes. Half a year. Half a year. Of course, we got tools for that, but if nobody monitors them, yeah, you get it. So, always assume breach. Deploy something new, assume that they're doing something with it. Best test, try to deploy an Azure VM. I give you 10 seconds before somebody from Northern Korea or wherever they're coming from, China, I don't care, even from the Netherlands, even from the United States, I give you 5 seconds before they actually start brute forcing that machine. Hey, new IP, let's do this. It's that easy. And that's why we're doing mitigations on that end too. We're blocking public IPs from the instant that we're now deploying VMs, and so on, and so on, and so on. So these are very important things. And very important, if you're doing identity, make sure that you're doing this. Oh, and now that I don't have any sound anymore. Okay. Typically she goes by, did you change the output? Lilo Dallas Multipass. What she's doing here, Lilo, Mila Jovovich, is actually applying multi-factor authentication. Multi-factor authentication combined with conditional access on any kind of system. I don't care whether it's AAD, Entra ID, Okta, whatever you have, but use it. Make sure that you have a secondary bypass of who you are. Yeah? And that's with anything. And you can do this for your private, you can do this for your public and your enterprise accounts, but at least enable them, even on AOL. Yeah, I'm looking for you. So, talking about the secure design part. And now it gets interesting. So, talking about the secure design part. Secure design, in the 1990s, Microsoft came up with a lovely acronym called STRIDE. Yeah, we're good at acronyms, by the way. Internally, we have a web page called Glossary, or what is it? Which has 3,500 acronyms and abbreviations. Take it from me, multiple of them are being reused multiple times, so we don't even know anymore what it means. But STRIDE was a unique one. And why was it unique? Well, it actually identified all the things that could possibly go wrong on a certain level, ranging from spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, where some of them go into confidentiality mode, availability mode, authorization and authentication. It's all these things that are being targeted. Now, remember STRIDE. We also added an additional one to that, DREAD. It's a dreadful acronym, but what does it stand for? Actually, it's a scoring mechanism for STRIDE. So if some of these things happen in the previous one, so let's say, for instance, spoofing, we want to make sure that we know what the damage potential is, what the I cannot say that. How you can reproduce it, how it can be exploited, and how many affected users there are. And in the end, you want to also make sure that how discoverable is this. If it's an exploit which is well publicly known, a lot of people will jump onto that. So these two combined will give you an easier way to do threat modeling. And threat modeling, simplifiedly explained, is what are you building? That's the model. What can possibly go wrong? That's the threat identification. What are you going to do about it? The mitigation. And then finally, did you do an acceptable job from 1 to 3? If so, you validated what you're doing right. Now, threat modeling is an easy or hard thing to do depending on how you start for it, but we also are here to help. And there's 2 tools on the market which are totally free that you can start using. And one of them is ours. Another one is written by a Microsoft engineer called Simone Curzi, and he did that as an open source project, but it's huge. It's called threatmanagerstudio.com. It's an online thing, and it has plugins for Azure DevOps and GitHub and GitLab and whatever you have, Word plugins and so on. But there's a simpler tool that we're using which has templates specifically. Of course, I'm an Azure lover. Sorry, I told you I was going to be talking about Microsoft anyway. But the threat modeling tool has templates for multiple platforms. And what does it look like is something like this. So we have, where did I... Of course, I need to open the correct window. So this is what it looks like. It looks a little bit like Visio, but with some default templates for Azure. And you're going to say, yeah, Mike, okay, everybody can draw, right? True. But what's so special about this tool is that this tool actually allows you to easily set each of these elements. So let's say, for instance, I'm going to take Active Directory here. It's an older one. You get all these properties and attributes of Active Directory. The way that you're going to select it, the way that you're going to work with it, how the communication works, and so on and so on. And all the connectivity parts like these are actually also proprietizable, saying whether they're on a physical network, where there's SSL, HTTPS involved, and so on and so on. You can contribute to the templates, you can contribute to the tooling itself. It's all open source. But the most important part here is, okay, but what do I do next? Well, remember Stride and remember the dread part? Well, there is, into the different viewing of the part, there is a, where is it, diagram? No. Where is it? View, here it is. Analysis view. So you have a design view, but also have an analysis view. And this is where you start identifying all the different threads. And I don't know where you can read it well, but there's a little column here called title. And this is where the, category. And this is where the specific Stride elements come back to life. The denial of service, the spoofing, and so on and so on. This will start being used as a mitigation list that you can then start exporting into an HTML file with all the different parts highlighted, and that you can use inside of your wiki for your dev teams and use this as a collateral for your technical debt and your security risks and how you can identify them. And if you don't do the export, which I already did earlier, you actually get something like this. Where is it? Here we are. You get a nice threat modeling report. Maybe make it a little bit bigger, with all the specifics highlighted. You get a full export, but you also, side by side, the different elements that are connected, you can actually get them into very small consumable images that you can then reuse in your Word documents or whatever risk reports that you need to involve. You also get some mitigations, you get some justifications, and you can export these as kind of an Excel file where you can then start using as a real mitigation list. So this is the first thing that I wanted to show you. Now, internally at Microsoft, we have a tool called the SDL Knowledge Framework. It used to be public, and hopefully we're going to bring that back. I'm in discussion with people of bringing that back into the public. What this thing does is actually building upon the threat modeling tool, but it also gives you the opportunity to look at all the different things that could possibly go wrong inside of a Azure deployed environment. So here you have some guidance that you can look for. And let's say, for instance, that you want to look for SQL Server or SQL. Let's do it like this. If I'm looking for these things, you will actually see that there's some things like database roles. And here you also have, for this one, there's no threats to this mitigation, but there's also specific roles in the warehouse that you can set. It's all these things that will make you understand better and make you understand what could possibly go wrong. So all the components, again, as you can see here, there's, for instance, API management. You have all the different things that can happen here. So API authentication, for instance, and there you have it. So here you have some threads that are mapped. An adversary may spoof requests, so you can do request spoofing, JWT token validation, client certificates, and also some of the descriptions of the things that could possibly go wrong. So it's good enough for you to know an awareness of the things that could possibly go wrong. So, that brings us to the second part. The developer is happiest where? In their IDE. Well, there's a couple of things that you need to take care of here. One of the things is that, remember that engineer had full access to his laptop, but also to an environment. You need to make sure that you narrow these things down. One of the things that we can do is giving engineers the best of breed fast machines, but in a very controlled way, without having them losing their boundaries as a developer on their local machine. One of the things that we can do here is make sure that everybody in the team starts off with the same image and the same deployable Visual Studio, IntelliJ, or whatever, with the same plugins installed, all managed through a developer lead / engineer. There's two things that we can do here. There's DevOps, which allows you to run a Win365 machine inside of the cloud from an Azure validated environment, immediately also injectable into your Azure development environment, talking to all the different aspects of your Azure environment, but also allowing the end user to install whatever they want on their machine through a monitored system. And they can make them as big as they want and as heavy as they want. And the nice thing is it runs just in the browser. They only need a thin client machine and it can run much smoother there. The other thing that we have is Codespace. GitHub's Codespace, or VS Code in the cloud, is hosted in GitHub. And why is this a security aspect? Well, if you have a dev container attached to that, which is just a small YAML file where you can set up all the plugins that they need, they can actually run that also from the browser, and everybody can do that into their own code space. So they get a heavy container immediately hooked up to the repositories and working from there out. Yeah? And this can then be managed through a security lead inside of your team, and that way you can narrow the attack surface for the developer part. Something that you need to know and realize when you're developing is all the things that you can inject inside of your code. And on that awareness part, one of the things that are important is things like OWASP. OWASP is the open web security protocols and all the things that could possibly go wrong. Read about it at owasp.org. Oh, by the way, I have QR codes for everything, so if you want a quick access, you can actually just do that. Every so many times they bring out a top 10, and they are also now not only moving into the web accessibility part, meaning just web pages and web apps, but also API specifications, specifically for APIs. We're injecting those inside of Defender for Cloud, so that way we can push that back into API management. So that way you can have the best practices for API security management on top of the already deployed things. Now, there's other similar orgs that will also give that kind of security insights. One of the things is SANS with the top 25, but there's also other things that you need to know about, like for instance CVEs, or common vulnerability and exposures. These CVEs are typically being handled inside of a database that all security tools can access, among ours, among Veracodes, among SNCs, among any other, and they're universal, so that way everybody knows what the typical security issues might be with packages, with specific code injections, and so on and so on. Very important to know. Now, if we're talking about code, there's a couple of things that you shouldn't be doing. And one of the things that you shouldn't be doing is injecting secrets inside of your code. Not inside of code, not inside of configuration files, but push the secrets where they belong. Key vaults, key management stores, and so on and so on. Now, typically developers have an issue with that because how do we approach these? Well, we have tooling for that. Most of the key vault systems that we have, whether it's managed HMS, whether it's key vault, whether it's the serverless version of it, you can easily just call them through SDKs that we have available for you and that you can just configure. So that way, a managed identity, which is not your identity, but an identity which is being managed between resources, or a service principal, which is more service account, can then use that key vault, take out the secrets in there after they're authenticated, and you know what, identity is still key here, even in a multi-factor way. Yeah? If you do, however, screw up and manage to inject secrets, first of all, I wouldn't be finding you, but second of all, we have tooling for that too. In the past, we had a little tool called CredScan. And CredScan was awesome. It was part of an extension made by Microsoft DevLabs. It was the ALM ranges that brought that out. It was in the continuous delivery tools for Visual Studio. So for those who are doing .NET, you could actually use CredScan as a CLI and inside of your Visual Studio. What does CredScan do? It recognizes patterns of the most recognizable secrets that are around. AWS S3 bucket keys, Azure SQL configuration, Azure SQL connections, storage keys, and so on and so on. Why are these so important? Well, typically if you have access to these keys, I get the keys to your kingdom. And you all know how that song goes, right? I got the keys, I got the secret. Yeah? This is about really guarding them. Now today, CredScan is available inside of all aspects of GitHub. And if you have a repository where you're gonna push your code into, we can actually actively block the commit of that key, making sure that no secrets whatsoever can actually get injected. If they do get injected, I'm gonna show you really quick, if they do get injected, here, you need to make sure that, there we are. Yeah, too many tabs open, like any other normal developer. So I have here secret scanning, as you can see. I have a couple of keys that have been exposed after the fact. And one of the things that I did here was a connection string that I injected. To make it really sure that it was in there, I injected it into a web.config in a text file. So it actually doesn't matter where it is landing. And as you can see here, the code itself recognized that it was a connection string for demo foobar dev2. It's a non-existing database, so you can hack away. It's not going to work. It has the user and it has the password in there, and it has been recognized as the valid SQL Server key. But it will also work for others, like for instance Google API keys and so on and so on. So we block this actively through the CLI, through Visual Studio Code, to IntelliJ, whatever. As long as you're using a Git-enabled repository in GitHub, we will actually block that for private and for public repositories. Then a little bit more on that OWASP and that sensing that I was mentioning earlier. As a developer, you do not always know by heart what could possibly go wrong. Now, there's a couple of nice analyzers that you can run during the development itself. There's Sec Intelligence. It's kind of deprecated, but it's very nice to look at. So look at the link. It has some nice documentation how we put things up. But one of the better ones that I like to introduce to you, specifically if you're doing .NET, is the security code scan by a certain Jaroslav Lobachevsky. He's an Azure security MVP, and he wrote this Roslyn analyzer a couple of years ago, and he's been updating this ever since. We even help him validate all the weaknesses in there. The nice thing is it injects inside of your Visual Studio, but you can also use it as an external NuGet package and even as a CLI tool to validate other types of code. And it has a full list with all the mitigations there too. Now today, Patrick this morning mentioned to you GitHub Copilot. Even GitHub Copilot can help you write more secure code. Not only from the parts where you say, hey Copilot, how can I make my code more secure? But even during the typing of your code, it will highlight certain more secure ways of handling certain things. Now, one of the things I do want to show you is the combination of security and Copilot inside of the GitHub environment. So here we have, where did I put it? And now I, of course, it's this one. Yeah, here we go. One of the things we introduced here is the auto-fix feature. Now, grain of salt, but it works seamlessly well with GitHub Copilot and something called CodeQL, because the indexing will not only happen on the code base that it can identify, it can also identify inside of your own repository, your own organization. But what the nice thing here about this is that it also works together with CodeQL. It will look for best practices based upon CodeQL databases, and it will introduce to you a fix that you will or will not commit immediately during your pull request. This will give you the leverage of identifying security issues before you actually fully commit them to your master branch and before you actually need to do a remerge or a baseless merge back into your repository. So this is a really nice feature that we've introduced a couple of months ago. Now, seeing that I only have 5 minutes left and I still have 400 slides to go, I'm going to speed up a little bit of the things. One of the things that I do want to mention is, anybody using Azure DevOps here? Oh, a lot of people. Okay. Know that there is an ADO scanner available, also part of the SIG Intelligence toolkit that we deprecated a couple of months ago. But that scanner is still actively being developed. Why am I mentioning this? If you have a Azure DevOps organization, you want to make sure that that organization is well configured and that you don't have that TeamCity incident that SolarWinds had. That's typically the thing. People don't know how to configure correctly with permissions that they're setting to everybody, but also not only to the people, but also to the environment. Think about path tokens to repositories that are externally. Think about secrets that have been injected as Azure or AWS or Google landing zones, and so on and so on. This thing will actually actively test and check for both organizational scanning and pipeline scanning, meaning how much access does my pipeline have to so many other environments. The only thing that you need to do is inject this little plugin, run it into a separate pipeline, and then put 2 widgets on a dashboard, and you will have the full result there available. It's a very powerful tool to identify secrets and privileges that have been malconfigured. And there's a lot of things going on there. Even it validates a little bit like we do in Defender for DevOps and Defender for Cloud. We have a little bit of kind of a secure score where we say, hey, don't have any externals inside of your Azure DevOps environment. It's stupid things like that that will actually make sure that your house doesn't burn down. Just like a little bit like, how do you call them? Fire alarms that you put into the house, which are now obligated in Europe. All right, I'm only still at the build part, but let's go for the one of the things that I want to mention here. There's a lot of building tools that you can do, right? One of the things that I want to show, what I really want to show you here is, which one I'm going to pick because I got like a 20-ish. Well, let's start with ARM-TTK. If you're building for Azure, you're probably building infrastructure as code. If you're not, come talk to me after this session and I can slap you silly. You should have infrastructure as code. Why? If shit goes down again, you can easily rapidly deploy somewhere else, but you can also evenly test your environment. Now, you need to test this environment too, and you need to test those scripts. If those scripts haven't been tested, because it's infrastructure as code, you also need to validate what's going on there. ARM-TTK will validate whether you're using the correct syntax, whether you're using the correct APIs, the latest ones, and also giving you some highlights of no, don't do this and don't do that. If you want to go a little bit beyond that, there's also a bicep linter available now for these things. Now, if you really want to push it into the limits and bring it back to another thing, then you have this little tool called the DevOps CLI. Or like I like to call it, Guardian vNext. Now, Guardian was a project that we did only for Unified and Premier support customers, so it was not free. But now we made it free. And this thing actually reports back into Defender for DevOps. What this thing does, it has multiple tools in there, like 3vScan, but also a bin skim. It does EAC controlling. It even did CredScan, but we took that out in favor of GitHub. And you can use this as a local tool, but you can also use this in your Azure DevOps pipeline. And this is something that I really want to show you. If you look at your security pipelines from your different projects, where did I put it? Yeah, it's this one. So I have here my developer pipeline, and this has having all the different aspects of security in it. All the different testing levels. I'm testing the code, I'm testing the deployment, I'm actually validating all these little things. And this is actually running, as you can see, the 2 red ones and the green one. This is actually this Defender for Microsoft DevOps Security CLI. It will test against multiple things. So here I'm running it. And it will test a lot of the interfaces. It does a bin skim, it does anti-malware if you maybe injected some malicious code, and so on and so on. So it's these things that will help you identify afterwards. Now, the cool thing here is that you can report this fully back into the Azure portal with Defender for DevOps. And this Defender for DevOps then allows you to validate whether your code was being pushed, like for instance here, whether your code has been pushed from within, let's say that you're building a Docker container. If your code was pushed from that repository, it will be highlighted here thanks to these tools, because they will report back inside of the Defender for DevOps. And it's a standard SATIF file that it has as an output. SATIF is a standard for logging all security issues, and from here out you can actually move on. This will give you nice reporting capabilities back, and it will also give you all the different security overview angles for all the code findings that it has, depending on the different tools that you implement. Like for instance here, I have infrastructure as code findings, which I can then take a look at from my repository. So it was this one. Oh yeah, by the way, I'm not a bad developer. This is deliberate. Actually, if I would do this in production, it would be the same. So we're not going to discuss that. But as you can see here, yeah, there's a lot of things that could possibly go wrong. And this is here where the infrastructure as code pops up then. And this is through the DevOps CLI that you can actually take a look at. You see all the findings here. You actually get a nice graph out of it, looking where everything is going from which entry point to which target, and so on and so on. It has a lot of information, plethora of information. Unfortunately, my time is already up. But you get the full slide deck. If there's one takeaway that I wanna show you still, is this headache slide. Yeah, it's intentionally giving you a headache. Why? Because end-to-end security doesn't stop at the build phase. It also stops at the deployment phase, the constant feedback loop, and so on and so on. These are all the tools that we have at your disposal to build a full secure development ecosystem for solution building. It's not only infrastructure, it's also developers, it's analysts, it's people that are impacted everywhere. So take this away. You will have the slides somehow. Hopefully somebody will distribute. I'm looking at you. And with that, having said, there's only one more thing to say. Big bada boom. Thank you for your attention.